Hey, take it easy, will you, Neil? You almost hit that car.
It's this pesky wiper. I've been going to get it fixed for the last couple of months. But, you know, when the sun's shining, I don't need it.
Maybe. To me, I'm not ready to join the harp chorus yet.
Okay, I'll take it in and get it fixed. There's nothing to the job.
So I told him I thought there was a lot more to wiper repair than changing a blade now and then.
And you're right, Marty, there is. Suppose I get some wipers and wiper parts out of stock, and Tech and I'll give you the story. Oh, here we are. Let's look at these three types of electrically operated wipers first. There's a single-speed made by both Autolite and Redmond, and a two-speed by Autolite. Single-speed wipers are being used this year on the Plymouth, the Dodge Wayfarer, and Meadowbrook models.
And all the other models use the two-speed wipers.
Right, Tech. But basically, these three wipers are a lot alike. The motors are bracket-mounted beneath the cowl with studs and nuts. Rubber grommets are used to dampen out vibration and noise.
You mentioned single and two-speed wipers, Alex. Just what is the difference?
Well, on the single-speed motor, you'll find a worm gear machined on the left end of the armature shaft. On the two-speed motor, worm gears are machined on both ends of the armature shaft.
Each worm gear drives a small diameter follower gear, which is enclosed in the end housing of the motor.
You'll notice that the follower gear is assembled to a crank arm. One end of the operating link is attached to this crank arm. The other end of the link attaches to a crank arm on the wiper blade arm pivot. During operation, the follower gear rotates continuously in one direction. The operating link moves the blade arm pivot back and forth, wiping the blade across the windshield glass.
Simple as that, huh? But tell me, what gives the two speeds to the motor? Got a resistance unit in the circuit?
Yep, there's a resistor at the parking switch. It cuts down the amount of current reaching the motor fields when the control switch is turned to the high-speed position. This increases the speed of the armature.
And don't try putting a resistance unit in a single-speed motor circuit. The motor isn't designed for two-speed operation and might burn out.
Tell me something else. What makes the wiper blades drop down out of the way when the switch is turned off?
That's because of the self-parking feature, my boy. You want to tell them about it, Alex?
Sure thing, Tech. There's a parking switch located right here. This switch is connected in the circuit between the control switch and the wiper motor. Actually, the parking switch is bypassed when the control switch is in the on position. However, when the control switch is turned off, the motor continues to run until the parking switch contacts are opened by a plunger. This plunger rides up a ramp on the follower gear as the wiper blades approach the parking position. As the plunger reaches the high point on the ramp, the contact points are opened and the motor is cut off.
Then the inertia of the motor carries the blades to the park position. Simple, huh?
Yeah, but what protects this wiper motor against overloads and shorts?
There's a 10-amp circuit breaker located in the circuit. On some of the early models, using the single-speed wiper, a box-type circuit breaker is mounted on the instrument panel brace. On later models, this circuit breaker is built right into the switch itself. On the two-speed wipers, all models have a separate box-type circuit breaker mounted on the instrument panel brace.
There's one thing you fellas want to remember about these windshield wiper circuit breakers. Be sure and use the 10-amp circuit breaker. Don't confuse it with the 30-amp circuit breaker found in the lighting circuit.
Right, Tech. That 30-amp circuit breaker wouldn't protect the motor in case of shock or overload.
What about adjustments? Suppose the blades don't drop clear down.
Adjusting the parking switch will usually take care of that. This reference book tells how to make those adjustments.
What about preventive maintenance, Alex? As far as the linkage and the motor is concerned, that is.
Lubrication is the important thing. Take the linkage, for instance. The felt washers on the linkage should be lubricated with a few drops of light engine oil whenever the linkage is removed, so the links won't bind.
You ought to oil the pivots with a few drops of light engine oil once a year. Just remove the oil hole screw in the pivot cover.
Well, what about other service operations?
As far as the linkage is concerned, you just want to be sure it's free and not binding. Another thing, if the bushings in the ends of the links get worn, replace the links.
You better inspect the pivots once in a while, too.
That's right. If they get worn so they're sloppy, the blades won't wipe evenly and cleanly. so you'll have to install new pivots. If you ever take that pivot out, force a little light grease into the oil hole before you put it back.
And always use a new gasket between the pivot bracket and the cowl, so you won't get a water leak.
Okay, Tech. But say, what do you suppose was wrong with the wipers on Neil's car?
Not having seen them, I couldn't say. How did they act?
Well, they were working, but awfully slow. Wouldn't keep the windshield clear.
Well, of course, if any part of the linkage was binding, the wipers would run slow. And high resistance in the electrical circuit could cause slow operation, too. So you'd check out the circuit with a test light and fix those loose connections.
As far as the motor is concerned, you can fix it like any other electric motor, or you can replace it.
That's about the story on electrically operated wipers, Marty. Keep the operating parts free, oil the pivots, and keep the electrical connections clean and tight.
I got a question, Alex. What are you doing for noisy wiper operation? On the Plymouth, for instance.
Well, there are a couple of conditions that cause noise, Tech. Take that motor hum that is caused by the mounting bracket being a little out of line with the mounting studs, for example. That lets the ends of the bracket contact the underside of the cowl. So, I just cut rubber or fiber gaskets a little larger than the mounting grommets and slip them over the grommets to prevent metal-to-metal contact at the ends of the bracket. That'll reduce the hum.
Good idea, Alex. I'll pass that along to the rest of the boys.
Another condition is where the link is either too long or too short. This will cause the pivot crank arm to come too close to the over-center position.
In fact, it can even go past center and stall the motor.
Well, what do you do, Alex?
Shorten or lengthen the link by increasing or decreasing the angle of the bends.
But you want to be mighty careful to maintain your alignment of the link ends, so they'll slip on the pivots easy-like and operate through their arc without binding. Hey, somebody better turn this record. I don't want to be talking to myself.
Right, Tech. Now, here's another condition that I've run into. If you ever have one wiper blade that doesn't make as wide a sweep as the other, here's what you do. First, reposition the arm on the pivot. If this doesn't correct the condition, remove the motor and examine the intermediate or long crank arm position. This arm should be offset slightly, 15 degrees clockwise to be exact, from the center line of the short crank arm. If this long arm is in any other position, replace it with a new one.
While you're at it, why don't you give Marty a rundown on the operation of vacuum-operated wipers? Maybe he doesn't understand all about them either.
You can say that again, Tech. How about it, Alex?
Okay, Marty. Remember, you asked for it. What do you want to know?
Why not start at the beginning and give me the whole story?
Okay. The motor is just a die-cast housing with an airtight paddle suspended in the center. On the same shaft with the paddle is a crank arm. The blade operating links are attached to the crank arm. In the cover, you'll find the on and off control valve and the parking valve. On cars equipped with a combination fuel and vacuum pump, the wiper motor is connected to the vacuum chamber of the pump.
Yeah, the vacuum pump. I understand that pump is what keeps the wipers from slowing down or stopping when you accelerate to pass a car. But I never did understand just how it worked.
You're getting ahead of yourself, Marty. Why don't you let Alex tell you how the wiper motor works before you get into the pump? You wanted him to start at the beginning, didn't you?
Okay, pal, don't shoot. I'll keep my ears open and my mouth shut while Alex gives out with the dope. Just forget I said anything about the pump.
Well, in the first place, vacuum is created on one side of the paddle. And normal atmospheric pressure on the other side of the paddle forces it to move to one side of the housing.
Right. And when the paddle reaches the limit of its travel in one direction, a little reversing valve goes into operation.
That reversing valve simply switches the vacuum to the opposite side of the paddle and lets air in where the vacuum was. That makes the paddle travel to the other side of the housing.
I see. Well, that's pretty clear. But I don't see where the vacuum pump comes in.
Well, here's how that pump gets into the act, Marty. The vacuum booster section is the upper part of the assembly. It consists of a vacuum chamber, inlet and outlet valves, a diaphragm, and a diaphragm spring.
That diaphragm is operated by the same rocker arm that operates the fuel pump diaphragm.
Right, Tech. The inlet to the vacuum chamber is through a pipe from the vacuum wiper motor. The outlet from the chamber is connected by a pipe to the intake manifold.
There's some vacuum in that chamber all the time the engine's running, Marty. But when the engine's under heavy load, that vacuum isn't enough to work the wiper, so the pump takes over.
Here's how it works, Marty. The rocker arm pushes the diaphragm up against the tension of the diaphragm spring. Then, as soon as the rocker arm starts down, the diaphragm spring pushes the diaphragm down. As the diaphragm goes down, it creates additional vacuum in the chamber, pulling on the wiper motor. So the wiper gets enough vacuum to operate it, even though the vacuum in the manifold is low.
So that's how it works. Say, my father has a car with a vacuum pump, but his wipers just about stop when he's climbing a steep grade or during a rapid acceleration. How come?
Sounds like low vacuum to me, eh, Alex?
Yep, he's got a leaking connection in the lines, a plugged breather in the motor, or a cracked diaphragm in the pump. Of course, a cracked diaphragm will cause high oil consumption, too.
Just wait till I tell my old man he's got a cracked diaphragm.
Well, you can check that diaphragm pretty quickly by using a vacuum gauge on the pump. Here's how you do it. Disconnect the wiper motor line at the pump and connect a vacuum gauge to the pump. Then, disconnect the manifold pipe at the pump and plug it. Then, with the engine running at idle speed, the vacuum gauge should show not less than 9 inches of vacuum. If it doesn't, the diaphragm is cracked and should be replaced.
If the pump is okay and the wipers still don't work right, check the connections for an air leak or repair the wiper motor.
I getcha. But tell me, what makes these blades park in the right place?
Remember that parking valve I told you was in the motor cover? When the control knob is turned to the off position, the vacuum is automatically switched to that parking valve. Then, as the paddle reaches the parking side of the housing, a flexible parking disc attached to the side of the paddle contacts the parking valve and is held there by the vacuum. So the blades always park in the same position.
I understand it now. And say, I sure appreciate you and Tech giving me the whole story.
He thinks he knows all about wipers now, Alex.
There's quite a story on wiper arms and blades, Marty. Want to get into that, too?
Gosh, I forgot all about the blades. Yeah, sure I do.
First, you want to notice that there are 2 methods used to attach the arm to the pivot. One type of arm is held on by a nut, while the other is held on by a spring.
And if the blade doesn't press tight enough against the glass to wipe clean, you bend the arm, right?
You do, and I'll bend your arm up your back. Set him straight, Alex.
Tension of the blade against the glass is controlled by a spring in the arm, Marty. Bending the arm won't increase the spring tension. You have to replace the arm.
I notice you've got several different blades. Are they interchangeable?
No, Marty. The design of the blade end of the arm determines which blade you use. For example, an arm with a flat end takes a blade with this type of attaching bracket. And an arm with this type of end takes the lock-on type of blade. You'll notice that the rubber insert in the blade is different too, Marty. You'll find the 5-ply type and the molded type. Each is crimped to the blade. Then, you'll find this replaceable insert type used in the more flexible or broken back type of blade.
Those blades are mighty important too, Marty. In order to do a good job, the insert's got to be good live rubber, free from nicks, oil, and grease.
You know, Tech, you just gave a good reason why wiper blades should be replaced every few months. A new blade gives a good, clean wipe.
Right, my boy. And if that windshield glass is oily, clean it off with alcohol.
Good point, Tech.
You better say a word about installing the arm on the pivot in the right position, Alex.
Yeah, that is important if you want to get a full sweep of the blade. You see, Marty, always install the arm in the parked position. Then, with the blade attached, wet the windshield and turn on the wiper motor. When you turn it off, the blades should park down at the bottom of the glass. If they don't, you'll have to adjust the position of the arms on the pivots.
That's what those little splines on the pivot are for, to let you move the arm enough to get exactly the right position.
Gosh, fellas, you sure made me understand how windshield wipers work, and why it is important to have them working right. You know, I'll bet a lot of accidents that happen during the rain or snowstorms wouldn't happen if the driver could see through the windshield.
You're just as right as rain, Marty. And remember, fellas, tomorrow somebody's life may depend on how good a job you did on that windshield wiper today.